Hi, welcome back. Today we're going to talk about some basic simulations that we can do with parametric equations. So I want you to take a look at the worksheet that I provided for today and see if you can answer the first uh, two questions and go ahead and enter the equations into your calculator. And go ahead and pause the video, do that, and then we'll talk about them. Okay, so if you think about the equations that you're given here, um, the x value for the first graph is just a number times t. And given the problem description, the 20 comes from Jerry's rate. So this equation must represent Jerry. And x will be his position in the race at any point in time, his position where the starting line would be at 0. It's just rate times time. So 20 feet per second for t seconds, it'll give you where he is at that moment. So the y value is a little confusing at first because there's no 3 in the problem. But if you, well, other than the 3 seconds in part B, but that doesn't seem relevant. If you think about the points that'll be plotted, Jerry's, if we're going to simulate this, Jerry's going to be running from left to right, let's say, at a rate of 20 feet per second, but the y value is going to be the same the whole time if we want them to be represented by a horizontal line. So 3 is just an arbitrary y value so that Jerry's position will be plotted along the horizontal line y = 3. You can put it wherever is convenient to space it out according to the window, your viewing window. Likewise, the 5 in the second parametric equation is also arbitrarily chosen. You just want these to be two different values that space the two runners out along the screen. Make sure that you take note of the fact that Jerry is, in the way they've set this up, Jerry is the runner who will be portrayed on the bottom, and Ben would be the one on top. Okay, so now the 20, you were asked the significance of that. We already said that was Jerry's rate. So the second set of equations, we already discussed the 5 is just arbitrary. The 24 is the rate at which Ben runs. And 10 is, if you look through the problem, it says that Ben gives Jerry a 10-foot head start. And so think about how they've used that in the problem. What does it mean to have a 10-foot head start? Well, if we put 0 in for time, you'll see that Ben's position is given as a -10. So that means Ben is actually going to start 10 feet behind the starting line. He'll be staggered back, and so he's got to run 10 feet just to get to the starting line. In order for us to kind of see the official start of the race, I would set the window up starting at 0 for the horizontal. That way you won't see Ben lining up behind the starting line, but you'll see him basically appear to start at whatever time he actually gets to the starting line. We can start the screen, we can make our left edge of the screen be a negative so that you can see that part, but until we get to figuring out how to draw in a vertical line so you could see the starting line, that might be confusing. So let's use the left side of the screen as a starting line for now. Okay, so let's set up our calculator. I've already put the equations in, and and we want to think about the window. So with parametric equations, you have to consider t and x and y, all of those things. T represents time, so we may have to do a quick calculation to see how long it'll take for the race to run. or we can just guess. And then if it's not right, we can adjust it. So let's say that I guess that it's going to take them 30 seconds to run this race. So we could let t go from 0 to 30. Now, the choices for xmin and xmax, I already said I wanted to let the starting line be the left edge of the screen, so we'll start at 0. The right side, let's make that the finish line for now. Well, it's a 100-yard dash. Be careful, that's 100 yards. So everything else is measured in feet. So that's a 300-foot race. So let's let x go from 0 to 300. And vertically, I want to make sure that 3 and 5 are spaced out on my screen. So we could go from, say, 0 up to 7. And that way, 3 and 5 are kind of central on the screen. So let's set the calculator up that way. We'll go to Window. And I'll type in 30 seconds for Tmax. I believe they told us to use t-step of 0.5. And we'll go from 0 to 300, as I said. X scale doesn't matter too much. It's just how far apart the tick marks are on the horizontal scale. And 0 to 7 vertically. And we'll put Y scale of 1. It doesn't really matter. Okay. Go into mode for a minute. And make sure we're in parametric mode. And we are. So, or else I couldn't type those equations in. So let's try the graph. Okay, so right away something's not really good about this because it appears that Jerry finished before Ben started. That can't be right. We know they run both relatively close together in rates, so they should be somewhat competitive. So let's go back to mode. This is the number 5 where it says, what's wrong with this? Why isn't it acceptable? Because it's letting one of the runners do the whole race before it even starts the second one. There was a note in part 37A that said graph these simultaneously, and there was a setting under the options under the window key or the mode key rather that we have to make sure we check off for simulations, and that is right here. We want to choose simultaneous rather than sequential. Sequential means draw a graph for y1 and then figure out y2 and then y3 one at a time. Whereas simultaneous puts in increasingly large t values for each graph and keeps them all updated as it goes through the process. So let's try that again. Okay, I'm going to hit enter to pause the action here for a moment. Notice where I paused it, the graph on top, which is Ben, is clearly won the race already. So according to our simulation, Ben won. We can do certain things to slow this down or speed it up by changing t-step. One of the things that's kind of nice to do on these graphs is to create little runners. If you go back to the y equals screen. But actually, notice I hit enter to pause it. It's got a little marquee at the top right of the screen, right up here, that's moving around to let me know I have the graph paused. It's not done. So if I hit enter again, it'll go ahead and finish its race, and that'll stop. That can be a problem if you allow way too much time for the race to finish. If I made my T max be really large, and it shouldn't be, then I may have to sit here waiting for it to finish. So one really important thing to know about these is if you start a graph and you realize that you did something wrong and you want to fix it, rather than hitting enter, which just pauses it, you can hit the on key, which aborts the current graph. Also, notice if I go navigating around and I come back to the graph, it doesn't redraw unless I've changed something. So if you want to see the simulation again, you need to either make a small change and then change it back, or simply go on top of one of the equal signs and hit enter, which will toggle that graph off, and hit enter again to toggle it back on. And that'll reset and let it graph. I'm going to go ahead and abort this partway through. I didn't get it, sorry. Let's try that again. So I'm going to toggle one on and off, restart the graph, and right away abort. Notice no marquee, it's not paused, and I can immediately go in and make changes or do whatever I want, rather than being kind of held prisoner by the calculator waiting to resume. Okay, I said I wanted to show the runners. If you go on top of the graph style part and hit enter, when down arrow to get to line, and if you go sideways, you can choose different thicknesses and so on, and there's choices to have a little circle for a runner. This one has a runner that leaves a trail behind them, but we don't really care about the trail, so if you go one more, you get just the little circle. And if I do that for each, I need to hit OK to choose that. And I can do that for the other runner as well. And it just makes it more of a realistic cycling the other way here. There we go. It does slow the graphing down. So what was a acceptable t-step may change. I may have to, this is going a little bit on the slow side. So if you wanted to speed it up, you could increase the t-step. Instead of 0.05, make it like 0.08 or something, and it would go a little faster. But this allows me to kind of photo finish. Definitely we see that Ben is pulling ahead of Jerry and will ultimately win. Okay. Part 7, since we've answered the questions prior to that, part 7 asks if we can add a finish line. So in order to do that, we need to we need an equation for a vertical line. And so like the 3 and the 5 for the Ben and Jerry's equations, how those were arbitrary, we'll create an arbitrary x value for the finish line. But it's not arbitrary, sorry. We want the race to be over when they get to the 300-foot mark. So I'm going to make a vertical line with an x value of 300. So okay, so I'm going to set a finish line with x equal to 300, and y, I just want it to progress across the screen, so I'll make it a multiple of t, and I just put a number in front of it big enough so that it'll only take a second or two to get across the screen. If you remember, my screen went from 0 to 7, so if I go by if I put this as a 10, as soon as I get to 1 second, it'll already be at 10, it'll be off the screen. So it just draws the finish line quickly and gets it out of the way. I've also gone ahead and taken the liberty of setting up my calculator. Since we want to see the finish line, I've increased the X max a little bit so that we can see 300 feet, not right at the edge of the screen. And I've increased the t-step with 3 lines drawing. It's going to slow things down a little bit, and I don't want to wait quite as long. You can see I've added the finish line here as the third function. And let's go ahead and watch it. There's my finish line drawing right away. Notice it's still kind of on the slow side, so I'm going to abort by hitting the on key and go to window, where I can adjust the t-step to